one of the two equations in a system of linear equations is given. The system has no solution. Which equation could be the second equation in the system? Okay, in the given system of two linear equations, we have one of the equations over here, and we have to find the other linear equation in the given answer choices. Okay, if the system of two linear equations has no solution, then both the linear equations must be in same format, and also the coefficients of x must be same, the coefficients of y must be same, and the constant terms must be different. Okay, now let me consider the linear equation in answer choice A. Now we have to write this linear equation in this format in which we have the given linear equation. For that, we have to make this 1 over 7 times x as 7x, because here we have 7x on the left side. Now to make this 1 over 7 times x as 7x, we have to multiply both sides of this equation by 49. Okay, now let me do it. That is 49 times 1 over 7 times x equals to 49 times 15y. Okay, 7 goes into 7 one time, 7 goes into 49 7 times, 7 times 1 is 7, 7 times x is 7x. On the right side, when I multiply 49 and 15y, I am getting 735y. And there is no constant term on the right side over here. So let's consider 0 as constant term. Then we can write positive 0. Now I got the linear equation in answer choice A exactly in this format. Now let's consider the system of two linear equations over here. As we have discussed, if the system has no solution, then the coefficients of x must be same, the coefficients of y must be same, and the constant terms must be different. Okay, here the coefficients of x are same, but the coefficients of y are not same. Then this system of two linear equations will not meet the condition. That is, the system has no solution. Actually, this system of two linear equations will have one solution. So we can reject answer choice A. Okay, let me erase the stuff. Now let's consider answer choice B. The same thing. That is, I have to get this equation exactly in this format. For that, we have to make this x as 7x. Let's multiply both sides of this equation by 7 to make this x as 7x on the left side. Okay, we have x equals to 15y negative 19. Let me multiply both sides by 7. Then I'm getting 7x equals to 7 times 15y negative 19. 7x equals to 7 times 15y is 105y, and 7 times negative 19 is negative 133. Now I got the linear equation in answer choice B exactly in this format. Let's consider the system of two linear equations over here. As we have discussed, if this system has no solution, same coefficient for x, same coefficient for y, and different constant terms. The coefficient of x over here is 7, and here 7. We have the same coefficient for x, and we have the same coefficient for y, and also we have the same constant term. According to the discussion we have done, the constant terms must be different, but here the constant term is also same in both the equations. Then this system of two linear equations will have infinitely many solutions, and this system does not meet the condition given over here. That is, the system has no solution. So we can reject answer choice B. That is, this cannot be the other linear equation. Now let me consider the linear equation in answer choice C. The same thing, we have to get this one exactly in this format. That is, we have to make this one as 7x. For that, we have to multiply both sides of this equation by 49. Let me write the equation as it is. It is 1 over 7 times x equals to 15y negative 99. Let me multiply both sides of this equation by 49. It is 49 times 1 over 7 times x equals to 49 times 15y negative 19. Here 7 goes into 7 one time, 7 goes into 49 7 times. 7 times 1 is 7, 7 times x is 7x. On the right side, when we multiply 49 and 15y, I am getting 735y. When we multiply 49 and negative 19, I am getting negative 931. Okay, now I got the linear equation in answer choice C exactly in this format. Let's consider the system of two linear equations over here. So the same thing, that is, we have to check whether we have the same coefficient of x, same coefficient of y, and different constant terms. We have the same coefficient for x, but we don't have the same coefficient for y. For whatever reason we have rejected answer choice A, for same reason we can reject answer choice C, because this system of two linear equations will not meet the condition we have over here. The system has no solution. This system has one solution. Okay, now let me erase the stuff and reject answer choice C. Now let me consider the linear equation in answer choice D. The same thing, I have to get this one in this format. For that, we have to multiply both sides of the equation by 7. Okay, now let me write the equation over here. That is x equals to 15y. Let me multiply both sides by 7. Then I'm getting 7x equals to 7 times 15y. 7x equals to 7 times 15y is 105y. And there is no constant term on the right side. Let's take a 0 as a constant term. Then we can write positive 0 here. Now I got the linear equation in answer choice D exactly in this format. Now let's consider the two linear equations in the system. We have the same coefficient for x over here, and we have the same coefficient for y, and we have different constant terms. So clearly this system of two linear equations has no solution. That is, this system meets the given condition. The system has no solution. Already we know that this is one of the linear equations in the given system, and the other linear equation is 7x equals to 105y passed to 0, and we got this linear equation from the linear equation in the answer choice D, that is x equals to 15y. So this x equals to 15y could be the second equation in the given system. The correct answer choice for this question is D.